Sam, I did promise you a video of some of the things from Unit 3 review, question 17, but looks like you were well on your way. Great job on completing all your work there. But I will just, for the sake of just doing it, talk about some of the parts of question 17. Um, so the question basically is decide whether you can use normal distribution to approximate the binomial distribution. So again, remember, on our graphing calculator, the binomial distribution can be very time consuming because we have to enter each one individually and then add them all up. This would be more appropriate building some type of spreadsheet. But if it's not necessary to do a binomial distribution, then doing a normal distribution to approximate the binomial distribution can be just as effective. Now, the catch is there's got to be certain things as far as when can we use the normal distribution. Remember that we have these two rules here. The sample size times the probability of success has to be greater than or equal to 5, and the sample size times the probability of failures has to be greater than or equal to 5. Also, we need to determine the mean has to be equal to, we have to determine the mean by using the sample size times the probability of successes. And we also have to determine the standard deviation, which is going to be the square root of the sample size times the probability of successes times the probability of failures. So in the first part, in our question, a survey of adults found that 7% say their favorite sport is auto racing. My wife and I saw F1 this weekend, and that changed my mind about watching F1 racing. It looked quite exciting. Anyway, you randomly select 300 students and ask them to name their favorite sport. So we're going to see where this takes us. So the first thing we have to pick up on is that the sample size, which was 300, we have to multiply that by the probability of success, which was 7%. We're saying 7%, we're going to say that. Is that indeed going to be greater than or equal to 5? And then we're going to multiply this 300 times the probability for failure, which would be 100% minus the 7% would be this 93%. Would that be greater than or equal to 5? So that's our first move. So again, we can use the calculator to do this. 300 times 0.07, and that's going to be 21. So 21 is going to be greater than or equal to 5, but also that's our mean as well. So on our normal distribution, we can put the 21 there as our mean. 300 times 0.93 is clearly going to be bigger than 5 because that's 93% of 300. That's quite a bit of it. So 279. So what we pick up on is, let's see here, start with that we can use a normal distribution to approximate the binomial distribution. And that's what you said here is yes. So right now, we know that the mean is 21. And the standard deviation is going to be the square root of that. Let's see here. So the square root of 300 times 0.07 times 0.93. So be basically the standard deviation, somewhere around there. So if I'm doing my normal distribution, one standard deviation would be you'd be adding this 4.42 to 21. That would be like 25.42. And if I do that again, so 25.42. Add again 4.42 to that, 29. So that's 29.84 we got here. So remember, if we're out past two standard deviations, the event gets quite unusual. And I could also do this the other way. I could subtract, I've got 21 minus 4.42. This is 16.58. Subtract 2 again. So it's like 12.6. So if we go out past 12.16, then that's going to be an unusual event. So as we move forward, we're just really just going to use technology to figure this out. So the question is, find the probability that the number of people who say auto racing is their favorite sport is going to be at most 26. Well, on average, we would be saying, 21. So at most 26, notice at most 26 means 26 or more. So 26 or more is going to kind of put us up in this area here, 26 or more. But now to do a continuity correction to include the 26, so I have to actually go left one and go 25.5 to include it. I'm sorry, at most, got that backwards again. At most means we can't go past 26, can we? So they're saying at most 26 means we can't go past the 26. So we have to understand that English there, which trips me up sometimes as well. So to be at most 26 means our continuity correction would be we have to use this 26.5 as our continuity correction. So when we use the calculator to do this problem, you can kind of see that a lot of the area under the curve is shaded, so we should have a pretty high probability. And it looks like your answer was. Um, so if we use the calculator, we go to distribution, normal cumulative. Again, our left bound, -1, e to the 99 is fine, or I usually type in -10,000 there, but since that's there, I'm going to leave that there. But so a big negative number. The upper bound will be 26.5. We can't go past that. The mean, we got 21 there. And then our standard deviation, I'm just going to put the formula into the calculator. So the square root of point, I'm sorry, 300 times zero point zero 0.07 times 0.93. That will avoid any rounding. So this should give us the exact answer. So that would give us then 0.8934. So that's what I'd be coming up with is 0.8934. Now, if we use 4.42, let's see where that would have took us. Let's see here. So if I clear that off and type in 4.42, it still gives me 0.8933. So I'm not sure where that's coming from, but that was still an acceptable answer. Um, Part B says find the probability that the number of people who say auto racing is their favorite sport is no more than 30. I'm sorry, is more than 30. So more than 30, 30 is going to be out here again. So if we look at that, you know, we know that, you know, out past 29.84 is going to be an unusual event. So I'm already kind of picking up on that. If we're out in this 30 area, we're going to probably be under 5% because of that. So what we're looking for is more than 30, but to do our continuity correction, we have to be at 29.5. So if we do that, we're talking about this area out here, 29.5 is our continuity correction. So when I do my probability, what we're doing really is the probability that X is greater than 29.5. That's basically what we're doing is that. So my lower bound is actually now 29.5. My upper bound is a big positive number, so I'm using 10,000 typically. It's just easier for me to type in. And, we could use those, but again, a lot of times to get the exact answer, I like to do the square root of the 300 times the zero point zero 0.07 times the 0.93. And then if we enter there, it gives us then this 0.0. Let's see here. I'm not getting this right. So more than 30, again, if we use our language here, not including 30. So our continuity correction should have been not to the left, but it should have been to the right. So you can kind of see you have to talk this out a little bit. This language here can be confusing. More than 30 means I should have not included 30. We're talking about 30.5. So it looks like that's where some of the confusion can happen here is which way do we go? And I think that may have been what you were having an issue with and you figured it out as well. So let's try that 30.5 and see if it made a difference. So my lower bound is because we're not including the 30, so we need to go to the right of it. Everything else should be fine. And we are getting what you got, which is the 0.0158. So that's where it can be off by a little bit is making sure you go the right way with the the continuity correction. So it looks like you figured that out. So I'll let that go. If you need me for anything else, just email me or text me. Great job on your exam.